Now let's step into the OT threat landscape by asking a very simple but powerful question. What is really at stake? What value is at risk when it comes to OT security? Here's the first example. JBS, the world's largest meat supplier, in 2021, they were hit by a ransomware attack that disrupted operations across multiple countries. To get their system back, JBS had to pay 11 million US dollars in ransom. That's not a small company, that's a global food giant, and yet they had to give in. Next is an attack that made headlines worldwide. We have talked about this before, the Colonial Pipeline ransomware incident. This attack nearly disrupted half of the fuel supply on the US East Coast. Colonial ended up paying 5 million US dollars to the attackers just to restore their operations. The scale of disruption here was not just financial, but it was also societal because fuel gas is a critical industry. People couldn't get gas. There were long queues for 10 days outside several gas stations on the US East Coast. Transportation services, emergency services, all this was affected. So the impact was also societal, not only financial. And then we have Maersk, the shipping giant. During the NotPetya ransomware cyber attack in 2017, their global operations were thrown into chaos. Ports were shut down, cargo was stranded, and overall losses crossed 300 million US dollars. And the interesting part, this wasn't even a direct ransomware payment. This was collateral damage from a destructive attack. So, as you can see, these aren't just isolated incidents. These are some of the biggest names in their industries, and they have all been forced to either pay millions or absorb hundreds of millions in losses. Attackers have figured this out too. OT environments are not only vulnerable, but they are also incredibly valuable targets. And that's why OT cybersecurity today is more critical than ever. Now, with that, let's dive deep into the OT threat landscape. So now that we have seen what's at stake in real-world OT incidents, let's look at where the risks actually lie inside industrial control systems. So this data here, this comes from a KPMG survey that analyzed cybersecurity risks to different ICS components like historians, workstations, servers, HMIs, and controllers like PLCs, RTUs. So at first glance, this chart looks busy. Don't get overwhelmed. We will break it down. And before diving into the numbers, let me first explain what each of these colored categories, what do they mean? Because that will make this chart much easier to follow. So, one of the categories that is flagged most is the operations from the network. So when we say operations network, that's the internal OT or plant network itself. This is where your PLCs, HMIs, historians, and SCADA servers all talk to each other. And if malware spreads inside this network, or if an attacker pivots between these devices, that counts as risk from operations network. So you should remember the Purdue diagram that I was showing you in that layer 3 was the operations network, SCADA systems, DCS systems, and then layer 2 was the PLCs and RTUs. So your HMI SCADAs from the layer 3 to layer 2, they were talking with each other. So if there is no segmentation there, attackers can pivot. Then we have another category that is flagged most is the business network. Now, this refers to the IT side, your corporate systems like ERP, MES, Active Directory, email and file servers. Remember the top 2 layers that I was showing you in the Purdue model? So when we see risk from business network, it means attackers are moving from IT into OT. And this is often through weak segmentation of flat networks where your IT and OT is not segmented and there's no DMZ between IT and OT layer and it's flat. It's a flat network. Then the next one is remotely by vendor remote access. So post-COVID, many original equipment manufacturers and service providers connect remotely to their customers to maintain equipment or troubleshoot issues. And if those remote channels aren't well protected, for example, if VPN credentials are stolen or insecure remote desktop is used, that's where the risks come from. And then the red category is from internet. This means internet exposure, so devices directly reachable from the public internet, either by mistake or intentionally, or maybe some HMI is having some VNC port and VNC software and VNC is exposed to the internet. So, or maybe PLC exposed to the public internet, so which can be found via internet scanning engines such as Shodan and Census. So that's counted here. Not remotely accessible, this category means that the device is meant to be isolated with no external entry points. Of course, we know isolation is rarely perfect, but this is how the respondents categorized it, that not remotely accessible, this is also one of the categories that is flagged. And finally, unknown simply means the survey participants didn't have clarity on the exposure. So the KPMG team, they sent out this survey to, I don't know, I'll have to check, to many ICS operators, and then the ICS operators responded to the survey, and then this was based on that data. Now that we have set the stage, let's walk through this chart and let's understand these different ICS components and what was the risk that was flagged for them the most. Starting with the historians, about 46%, the maximum risk came from the operations network. That means malware or attackers spreading laterally inside OT is the biggest threat to historians. And around 38% came from the business networks, showing how IT to OT pivoting can reach historians. And the internet exposure is relatively small, only 5%, but it still exists. Some organizations might even expose historians to the internet, which should not be the case. You should never expose data historians to the network, to the public internet directly. Because historians, as we saw, they are dual home devices. That means they talk to the OT side, to the field devices, collect the logs, data, and then they process this data and then forward it to the IT business layer side, to ERP or accounting software or planning software. So historians are dual home servers. They talk both to IT and OT, and if they are not properly segmented, protected, they can be used as bridge to move between IT and OT. Next is workstations. So operator workstations. So here the top source of risk is also again operations network, 53%, which is followed by business network around 32%, and internet exposure is again limited, around 12%. So the big story again here is lateral movement inside OT environments, no kind of segmentation between these components, these devices. For servers, the numbers again look very similar, 51% from operations network, 37% from the business network. Internet exposure is again 13% less than operations and business network. HMIs that are used for interfacing with the machines, this is interesting. More than 56% risk comes again from the operations network. That means once the attackers are inside the OT environment, HMIs are highly vulnerable. Attackers know that HMIs are the devices that will get them directly interfacing with the machines, and they can directly create an impact. About 23% from the business network, which means from the IT side. Internet exposure is low, 7%. They should be zero actually. You should never expose HMIs to the internet directly. Then you have controllers, PLCs, IEDs, RTUs that are controlling the field devices like sensors, actuators, so the brain of your OT environment. And over 50% risk again comes from the operations network. Around 26% is coming remotely by the vendor. This is interesting. After COVID, there was this trend when there was a global travel ban. Then a lot of industries worked on building remote access solutions, and then due to global travel ban, a lot of companies started taking remote access support from machine builders and original equipment manufacturers to maintain their environment. And this was, since it was a need born out of urgency, this was done poorly. People still use site-to-site VPNs or VPNs. These are legacy. Remote access solutions should never be used. There are new remote access solutions on the market which come with a lot of additional security controls adapted to this need. We will talk about this remote access in detail in the section 6 in the ICS security fundamentals, where OT secure remote access is one of the critical security controls recommended by SANS. So we will discuss that in detail there, what kind of solutions you should use for remote access. But yeah, it was interesting. Around 26% of threats came from the vendors through the remote access to this. Only 6% from internet. And this makes sense because PLCs are rarely directly exposed to the internet, but they are highly vulnerable once an attacker is inside. This is the brain of OT environment, as I said. They directly control the robotic arms, field devices. So what's the big takeaway then? Most of the risk to ICS components doesn't come directly from the internet. Instead, it comes from within the OT network itself and from connections to the business IT network. This is why then segmentation between the IT layer and the OT layer, between IT and OT, and having a DMZ for 12 home servers is very important, and then putting in strong access control and building a secure remote access solution are very critical in the OT environments. Now, when it comes to OT security, most people instinctively think internet exposure is the biggest risk, including me. I was also thinking the same, but when I read these reports online, when I saw the survey, it changed my thinking, because the survey showed that direct internet exposure is relatively low in OT. The real danger is the lateral movement inside the operations network. Once malware or attacker gets into one device, weak segmentation lets them pivot freely to others. And attackers know that on the OT side, there are rarely authentication and encryption implemented, because OT devices intrinsically lack these security controls, and that's why then attackers know that lateral movement will get them to one of the devices to create impact. And that's why over 50% of the risk is in every category is tied to the operations network. So bridging points between IT and OT systems like historians, jump servers, remote access servers, or dual home servers that are going to talk to both OT network and IT network, if they are not properly placed in a DMZ with strict one-way data flow, they become perfect pivot points for attackers. So yes, the foundational defense here is network segmentation. Separate your IT and OT. In the Purdue model, level 4 and 5 I was showing you as your IT layer, and 0 to 3 was your OT layer. Between that, there should be a firewall. Between that, there should be a DMZ, and enforcing one-way traffic rules and strict access controls to prevent OT systems from directly exposing unnecessarily. We will talk about segmentation more in detail with the architectures and blueprint in section 6 when we are going to discuss ICS security fundamentals. For this slide, in short, the data shows once attackers get inside, lateral movement in the operations network is the number one risk for OT systems. So your operational network should not be flat. It should include only SCADA, HMIs, these kind of devices, and plus there should be some kind of micro segmentation between them. And your field devices, your controller devices should be in another zone, and there should be a firewall in between operation zone and control zone, and plus your business zone, operation zone, they should also have a firewall. So yeah, that's all on this slide. Then let's move ahead in this section and look what's more in the OT threat landscape. Now that we have looked at the bigger picture of where the risks come from to the ICS components, now let's go one step deeper. Let's categorize those risks, and let's break it down layer by layer of how in a typical ICS or OT environment we see the kind of threats at each level for these components. So we will start at the top, the enterprise infrastructure layer, also called level 4 or 5. This is the business layer that I was referring to on the previous slide. So this previous slide that we were seeing, and here the business network that we referred to, this is your layer 4 and 5. So this is your IT zone, ERP systems, email, file servers, enterprise apps. So the threats here usually are IT related, things like remote access to OT systems through misconfigured firewalls, poor segmentation, lack of monitoring. So if this layer is not properly secured, attackers can pivot from here, that is from IT towards OT. The next level is 3.5, the OT DMZ. This layer contains systems like MES, lab servers, patch management servers, remote access gateways. So ideally, this is the buffer between IT and OT. And if the firewalls are weak, remote access is poorly managed, or if logging and monitoring are missing, then the DMZ becomes a weak point for the attackers to exploit, as this is a bridge into the OT from the IT side. And then on level 3, you have site operations. You have components like historians, OPC servers, engineering stations. These systems are critical because they often talk to OT devices and IT databases. Like historians, it talks to both OT and IT. From the OT side, it collects logs, process data, processes it, and then feeds it to ERP, planning softwares, accounting softwares on the IT side. So it is kind of a bridge between IT and OT. It's a dual form server talking to both homes, IT and OT. So threats here include insecure role-based access, weak control over data transfer, and IT-related risks. So if this is compromised, attackers can learn the entire process flow and even inject malicious commands downstream into OT. Then at level 2, we have the supervisory control layer. We see SCADA systems here, control servers, HMIs. The risks here are very similar: insecure access, weak authentication, unmonitored data transfers. And if this layer is breached, operators may lose visibility or control of the plant. As I said, that in HMI, SCADA, though they are running on Windows workstations, we cannot simply install 10 different endpoint security softwares that you usually see on the IT side, and you cannot force users to use unique username and password for each user. You have to allow generic users a shared username and password for a group of operators, so that HMI is never locked. Screen lock, encryption, these kind of policies, you have to give security discounts here. You cannot enforce those here because of safety reasons. So because of these security discounts that you have to give for these workstations, insecure access, weak authentication, non-encryption, these are the risks I'm showing here. Now, one thing to notice here is that, in the Purdue model, I was discussing with you that historians should be placed in DMZ, SCADA, and HMI are on the site operations layer on the level 3. But here, it's shown different in this report. The reason that these placements don't look typical to the Purdue model layer is because historians are, because here they are shown closer to the level 2. The reason is that in real world plants deployments, they don't always match the reference architecture. Vendors and operators will often blur the lines, and this report, then the KPMG report that is showing these threats to these layers, they are simply trying to match those practical realities. As OT security professionals, when we are designing the segmentation, that is when we will suggest in our design that historians are also dual home servers and they should be put into DMZ and SCADA and HMI. Maybe they should have some kind of segmentation between them. If a SCADA is managing the entire site operation, it should come in there. It's not a local supervisory control and those kind of things. With that, let's move on to level 1, the basic control layer. This is the brain of your OT environment. So the threats here become more physical: infected USBs carried by engineers, unsafe file sharing, and then outdated firmware, shared passwords, weak configurations. And many of the devices here are 20 or 30 years old, and they were not built with cybersecurity in mind, because 20, 30 years ago, world was very different. Some of the industrial revolutions like AI revolution, Industry 4.0, smart factory are fairly just 4-5 years old. Finally, at the bottom, then you have the field devices, the sensors, pre-actuators, actuators. This is where the physical world connects. The sensors, actuators, motors, valves, they connect to each other, pipelines. And the threats here are hard-coded passwords, vulnerable components, insecure protocols, backdoors, and missing logging. So if attackers manipulate this layer, it directly translates into physical consequences. Machine shutting down, valves opening, or safety hazards for people, those kind of things you see here. So layer by layer, we see a recurring theme if you see here, weak segmentation, outdated devices, poor authentication, and insufficient monitoring. So, by understanding these threats at each level, we can then design stronger defenses that are tailored to where the risks actually sit. So, uh, if for an HMI you cannot enforce unique password for each user, and you have to allow username, generic user and password to be shared amongst 5-10 operators, then maybe you will compensate that with some kind of network security control like micro segmentation. So whenever you cannot install endpoint security controls on the workstations, you complement them with micro segmentation, building tight segmentation rules for the network connections that are originating out of these devices. So compensate them with network security controls or some other compensating controls. So like this, when you understand the risks, then you will be able to think of these controls. So notice the pattern here that I want to show you. The higher the layer of ICS stack, that is 4 and 5, these are the higher layers, right? Like enterprise and DMZ. The risks that they carry look very similar to IT. That is misconfigured firewall, poor access control, lack of monitoring. But as you move down the layers to the south, you will notice the pattern that the risks become more OT specific. Things like infected USBs, outdated PLCs, and hard coded passwords that can directly impact the physical processes. So, on these two layers, you will not find patching or this kind of USBs, this kind of issue, because in the IT layer, patching and USBs and these are taken care of. But here you will find the patching and outdated software as the risk and USBs as the risk. So yeah. So in short, the higher you go into these layers, the threats are more about data and business disruption. And the lower you go down the south, the threats translate into real world safety and reliability risks. And that's why segmentation and tailored defenses at each layer are absolutely critical. So here on the IT layer, if an attacker compromises, he will mostly compromise data and some information loss, but you will still not have any kind of safety hazards. But here, if the attacker compromises OT side, you will have potential safety hazards to human life. Now, before we move on, there is one more graphic here that I've added. Let's not forget this. This is more of focusing on people. So this is technology, and technology is just one piece of the puzzle of OT security. Alongside the technical risks, we also have organizational and process-related risks that I'm showing here in gray. So, for example, untrained professionals, lack of awareness, they are some of the major concerns, because even the best security tools can be rendered useless if the people operating them don't understand OT security basics. So you can put all the firewalls, implement all kind of segmentation here, but if you're allowing too much of traffic, too much of holes in your firewall, then that will defeat your segmentation. And for that, there should be some proper processes in place for allowing new traffic, change of firewall rules. We will discuss about the processes and people and governance in section 7 in detail, like what kind of governance you need to implement OT security and what kind of processes you need in an organization to bring that governance into effect. We will discuss that in detail in section 7. I have dedicated a section for that. So then there is also this improper segmentation of legacy systems. Many plants run equipments that are 20, 30, sometimes 40 years old, and these systems were never designed with security in mind. Patching, configuration, change management, all that is inconsistent because in OT environments, downtime is costly. Then some of the other risks also include poor asset management, weak backup management, and growing supply chain risks, where vulnerabilities in vendor supplied software or hardware can become your problem. So, proper vendor vetting and proper inventory management, all that is needed. We also see cases where decommissioned devices are left connected, or where identity and access management is weak, leading to shared or default accounts still being in use. And so network visibility and monitoring is also, an asset inventory is also one of the critical OT security controls recommended by SANS that we will discuss in detail in the next section, section 6 of ICS security fundamentals, and what kind of tools we can use there. And then finally, many organizations still lack well-defined policies and procedures, a well-defined governance, which leaves gaps in accountability and enforcement. So you should have a proper OT cybersecurity committee. You should put people on that. You should have an organizational chart, put names of people who will be responsible, accountable, and we will discuss that in detail in section 7 in the governance of OT. So the message here on this slide is that OT threat landscape isn't just about malware or exploits. It's also about this people, processes, and governance. If these areas are weak, the technical defenses won't be enough. No matter how many technical defenses you put in, you can throw in newer modern technologies like zero trust, but you will fail if people, processes, and governance don't come together. So yeah, a dedicated section on governance and processes, we will discuss more on that. 2 sections from here. All right, that's all on the slide then. See you in the next one.